In this video, we are interested to look at measures of variations in the data set. So variation is basically indicating how much does the data vary across all the data points. And there are 5 measures of variation. The first one is the range. Very simply, it is maximum minus the minimum value in the data set. So basically look at the end points of the data set and take the difference to see how the data set varies across all the data points. The second measure is the what is known as interquartile range, which is nothing but quartile 3 minus quartile 1, which is looking at the middle 50% of the data set. Now both the range and interquartile range just looks at 2 points in the data set. Range looks at the max and the min. Interquartile range looks at the 75th percentile and 25th percentile. But if one is interested to look at all the data points, then we would want to look into what is known as the variance of the data set. Derived from that, the other measure of variation is standard deviation, and again derived from the standard deviation you will get what is known as coefficient of variation. So our interest focus right now is we take an example data set and see if we can figure out how much is the variance, standard deviation and coefficient of that particular data set. Right, the variance of the data set is xi minus x bar squared over n minus 1, and here's take an example of a data set. Here's the value of x, and then you are interested to find out how far is each observation from its mean value. Right, so when you think about variation, right, variation compared to what? Compared to the center point. Center point of a data set is nothing but the mean or the average of the data set, right? So how far is each observation from its center point, which is nothing but the mean? So first figure out that. So we need to figure out the mean first, obviously. The mean, if you obviously would know, it's a sum of all the values of the data set. Here's xi 10, 20, 10, 40, 30, 10, 15, 30. You get a total of 200, and that is nothing but you add all across all observations, and then you have 8 observations, and hence the mean turns out to be 200 over 8, which is 25. And so now we are interested to find out how far is each of these x value from the center point being 25, right? So 10 minus 25, 20 minus 25. You do across all the individual observations to see to figure out the variance. And if you just take the deviations and see how far, if you just take the deviations from the mean, and if you just add these numbers up, you'll get 0. Now when you look at this, a number called 0, it appears that, well, there is no deviation, right? Clearly there is deviation. These data points are not all the same numbers, they are different numbers, and hence there is definitely some variation in the data set. There is some change in the numbers or values of each data point, and hence if you just look at this 0, which is sum of all the deviations from the center point, then it gives an impression that, well, there is no variance or there is no change in the data distribution. Now hence to make sure that we penalize all the deviation, we square these terms. So we square all the deviations. Now when you square all the deviations, of course any deviation from the center point is now being penalized, and hence you would not have a total of 0, because you're penalizing every single deviation by squaring that, right? So effectively, if you think about this observation, it's negative 15 square, and if you look at this 40, it's 15 square, right? Now whether you look at 10 or 40, effectively you're saying that the 10 is 15 below the mean and 40 is 15 above the mean. It really does not matter. They are not in the center point, or they are equally away from the center point. The center point is 25, and hence 10 is seen the same way as 40 in some ways, because both are 15 points away from the center, the mean, which is 25. And hence when you square it, you effectively are saying 225 and 225, they are exactly the same in terms of deviations or in terms of variance, right? And hence squaring becomes important. So when you take the average of all these deviations squared, so xi minus x bar square, and when you add across all observations, we end up getting 1600. You can do the math. I think it's straightforward. And to get the variance, you look at the sum of squared deviation and then divide by n minus 1. So variance we represent by s square of this variable called x. It is nothing but sum of all the xi minus x bar square squared across all observation, and then divide by the total number of observation minus 1. So we have here is the numerator is 1600, and you have 8 observations and then minus 1. That will give you 228.571. That is your variance. Now, the problem in some ways with the variance is the interpretation of it. Notice that you have a square deviations, right? So you are basically squaring every single deviation from the center point. And hence, when you square this, if these numbers are say in dollars, you would end up squaring the dollars, and hence, as far as the units associated with variance are concerned, this would be dollar square if dollars is your unit, which is very difficult to interpret. And hence, to come back to our original unit, we then look at what is called the standard deviation, right? The standard deviation is nothing but the under root of the variance, and that is the under root of 228.57, and that gives you 15.1. Now this has original units back because you are taking the under root of a square, and hence you get back your original units, and hence this interpretation is now in the original unit of the data set. So if the original data set was having a unit of dollars, then standard deviation is in dollars. Variance will be in dollars squared. Derived from standard deviation is also what we call coefficient of variation. Now, coefficient of variation is basically 15.11, which is the standard deviation, and the mean we have 25. And multiply by 100, you get 60.47%. Right? So here you are basically saying, well, the deviations are 15.1 average deviations, but it is relative to the mean of 25. And this makes comparison across different standard deviation straightforward.